Now we'll look at molecular compounds. Molecular compounds contain nonmetals, and we can't figure out their formulas based on charges because nothing has charges. These are held together by covalent bonds. There aren't any ions. And there are lots and lots of different combinations of even the same two elements. Here's an example with nitrogen and oxygen. There's I don't know where that went. There are 6 unique molecular compounds that actually exist between nitrogen and oxygen. They each need to have a unique name. So we have a different set of rules for molecular compounds. Students like this set of rules and they try to use it other places. You can only use this if you have 2 nonmetals, okay? So we use numerical prefixes, the same as for the hydrates, except there's no hemi. We use these prefixes to tell how many atoms of each element are present in the compound. And which element goes first? It's the more metal-like element. So how do you know what that is? Well, generally it'll be the element with the smallest group number, the element furthest to the left, which kind of makes sense because we read left to right. So as you're going across the periodic table, the element you come to first is generally listed first, and the other one is listed second. And that's not really going to be a big deal. So we are going to look at binary molecular compounds, 2 nonmetals. So this is how their names work. We use a prefix in front of the name of the first element to tell how many there are, and a prefix in front of the name of the second element. But here, the element changes its name to "ide" as if it was an ion, but it's not. So, NO2 is called nitrogen dioxide. And just like we omit the 1 in the formula, we don't write a subscript of 1. We often omit the prefix mono in front of the first element. If you write the prefix when it doesn't belong there, I won't mark that wrong. But you'll see some things where you're like, well, why didn't they put the prefix there? Well, it's this little exception thing. And we'll do some practicing with this. And this is very important. H2O and NH3 always use their common names. H2O is water, and NH3 is ammonia. Okay, and I might try to trick you with those. Because we could give these systematic names, and they have them. This would be dihydrogen monoxide. And so, if you want to alarm your family and friends, say, we drank dihydrogen monoxide in class tonight. Oh, yeah, water. It's a chemical. And ammonia could be called nitrogen trihydride, right? But we never call it that. We call it ammonia. So let's look at a couple of examples. Let's name this compound N2O5. Use a prefix in front of the first one to tell how many. So there's 2, right? What's the prefix that means 2? Di. And that element's name is nitrogen. So dinitrogen. And how many of the next one? 5, penta. And that's oxide. Okay. You also see a little bit of variability when you have double vowels there. Sometimes one of them gets left out and other times not. Let's write the formula for phosphorus tribromide. There's no prefix on phosphorus. How many are there? Just 1. So that's P. And then tribromide means what? 3 bromides, so Br3. The reason students like this is it's just a lot more straightforward, right? But only with 2 nonmetals. So, any questions about that? Yeah.
So say in the exam we have to like fill in and phosphorus and like the typo like phosphor OUS. Would you fix that?
No. So there are different spellings. There's British English and American English. And so phosphorus is sometimes OUS and sometimes it's US. And so I'm not going to make a deal about that. And sulfur, I think the British spell it with a PH instead of an F. Yeah. So, no, that's fine. I prefer the American English version, but the other English version is not wrong. Okay. Any questions?